I've been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Algebra Unit 8, Lesson 1. We're going to be looking at quadratic functions. So this will be our intro. So I'm just going to remind you of something we learned already, which was a linear function. That's what we studied most of the year. A linear function is a function with a constant rate of change. And the equation that we usually see is either standard form, which is ax plus by equals c. For example, 3x plus 5y equals 15. Or y equals mx plus b. And that would be something like y equals 5x minus 2. Remember, 5 is the slope and negative 2 is the y-intercept. So you would start at negative 2 and you would go up 5 over 1. So that's what a linear function is. Remember, a linear function looks like a straight line on the graph. A quadratic function is any function that can be written in the form ax squared plus bx plus c, and that would be equal to y. And we've been working with this, but we haven't really talked about what a quadratic function is. It's important to know that a, b, and c have to be real numbers, which are the only numbers we've been working with in this class. But also a can't be 0, because if a is 0, then what happens is this term goes away and then it just becomes a linear function. So a cannot be 0, otherwise it's not a quadratic function. In other words, you have to have this x squared piece. A quadratic function does not have a constant rate of change. Does not have a constant rate of change. So when you look at the change in y versus the change in x, it's not going to be the same, and we'll look at that a little bit later. So we're going to graph y equals x squared, and the way that I'm going to do this is I'm just going to plug in values for x and then evaluate them to determine what y is. So if x is negative 3, I'm going to do it over here, then I'm going to square that, which is going to give me a positive 9. If x is negative 2, when I square that, I get a positive 4. Notice that when I square a negative number, I always will end up with a positive number. 0 squared is just 0. 1 squared is 1. And 2 squared is 4. And 3 squared is 9. I'm going to go ahead and add that. So 1, 4, and 9. So now I'm going to plot these points. So negative 3, 9, and I have negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So those points form this quadratic, and the shape that it forms is called a parabola. Parabola. That is the shape that is formed by a quadratic function. This is the parent function of quadratic functions. It's the parent function. All your quadratic functions should have a parabolic shape. In other words, it should look like a parabola, but they won't all look exactly like that. And again, we'll look at some examples. So we're going to determine if the following are quadratic. Remember, we said that a quadratic function should have that equation or something that can be written that way. And also, it does not have a constant rate of change, and it looks like a parabola when you graph it. So looking at this first question, it's a table. So let me find the rate of change and see what I notice. So from 8 to 2 is minus 6. From 2 to 0 is minus 2. From 0 to 2 is a plus 2. From 2 to 8 is plus 6. The change in x is always plus 2. So notice that the change in y is different, but the change in x is the same. So the first rate of change is negative 6 over 2. And then the second one is negative 2 over 2. And notice those are not equal. Therefore, this is not linear. Now, how do we know for sure that it's quadratic? We know that it's quadratic because we're going to find what is called the second difference. So I'm going to find the difference in the first difference. So this is my first difference, these 4 numbers, and this is going to be my second difference. If the second difference is the same, then it is quadratic. From negative 6 to negative 2 is plus 4. From negative 2 to positive 2 is plus 4. And from 2 to 6 is positive 4. So this is indeed a quadratic function because the second difference is the same. The second difference is the same. Letter B is an equation, and I notice that I have this x squared piece, and I've got a coefficient in front of it that's not a 0. So that looks to me like it would be a quadratic. All right, so now we're going to look at an example problem and talk about some more vocab and just kind of what's going on here. So the function is f of x, remember f of x is just y, equals negative x squared minus 10x minus 21. And I went ahead and graphed this parabola for you. You will need to know how to graph parabolas. Right now, you're just going to graph them like I did here, where I gave you the x and you plug in to find the y. So let me just give you an example of this really quick. So what is y going to be? Y equals what when x equals negative 2? Okay, so let's see what happens. So I'm going to plug in a negative 2 wherever I see x. And I'm going to solve for y. So f of x, that's just y. In other words, f of negative 2, what is the function equal when x equals negative 2 equals negative parentheses, negative 2 squared, that's important, minus 10 parentheses negative 2 minus 21. Okay, so I just replaced the x with a negative 2. Now I simplify. Negative 2 squared is 4, but there's a negative in front of it. Negative 10 times negative 2 is a positive 20 minus 21. Negative 4 plus 20 is 16. 16 minus 21 is negative 5. So f of negative 2, in other words, the y value when x equals 2 is negative 5. So this should be a point on my parabola, and in fact it is right here. Okay, so that's how you can graph the quadratic, by plugging in values for x to find y and then plotting the points and seeing the shape that they form. So first thing I want to look at is what is concave up and what is concave down. This example here is concave down, which means that it opens downward. Okay, so it's kind of like this U shape. Concave down is when the parabola opens down. Concave up is when the parabola opens up. Just a note here, this is not a quadratic function because it's not even a function because it doesn't pass the vertical line test. So you're never going to see one looking like that. Concave up will happen when A is positive. Concave down will happen when A is negative. So if we go back and look at our original function, notice that my A was negative 1, negative being the key there. That's why this is concave down. It opens downward. Vertex. What is the vertex? The vertex is the highest or lowest point on the parabola. There is only one vertex. So what is the vertex on our parabola here? Well, it doesn't have a lowest point because this goes down forever and ever. But it does have a highest point. So this is the vertex. And the ordered pair for that is actually negative 5, 4. And it's pretty easy to see from the graph there. Later on, you'll learn more details about the vertex. Right now, all you need to know is that it's either the highest or the lowest point on the parabola, and you need to be able to find where that vertex is when you graph it. So our example is negative 5, 4. Maximum minimum is related to the vertex. So the maximum is the vertex when the parabola is concave down. So if my parabola looks like this, then my vertex, notice, is a maximum. When my parabola looks like this, my vertex, the highest or lowest point, is a minimum, because if it goes up forever, that can't be the maximum. So a parabola always has a vertex, but a parabola cannot have both a maximum and a minimum. It's one or the other, depending on if it's concave up or concave down. And remember, you should be able to identify if it's concave up or concave down based on this up here. A is positive, we know it's concave up. A is negative, we know it's concave down. The last thing I want to talk about is the domain and range. The domain of a quadratic function will be all real numbers unless it is a specific problem situation like a real life problem. Okay, so remember, domain is the x values. So because this parabola comes down forever and it's also getting wider, that means the domain can be anything. But when we talk about the range, range is y. So we're looking from bottom to top. Well, if this goes down forever, there's not going to be a boundary down there. But what is this up here? It stops. So our range is going to use the vertex. The vertex will be used to determine our range. So the range for this specific example is going to be y is less than or equal to 4. Again, there's only one boundary. So everything less than or equal to 4 is where the parabola lies. Those are the possible values. It cannot go larger than 4. So you're going to use the vertex to find the range. All right, so that was your overview of quadratics. I know it probably seems like a lot. Make sure you have all those vocab words and have an understanding of them. Feel free to look in the book in chapter 9. Chapter 9 is the first section, and you can maybe get some more information there and answer any questions that maybe you were confused about from the video.
I've been waiting way too long. Yeah.